There should now be sound. Awesome. Okay. Thank you, Amit. All right. Getting all the bugs out the way. This is the first time that we're doing this. And let me just get back to other view. Okay. Okay. Great. All right, guys. Audio's fixed. Yeah, so just to reiterate what I was trying to say when there was no audio, this is the first of the serverless live sessions, and we're already picking up a few viewers, which is pretty cool. And I'm also combining this with the serverless office hours that we're going to run for the next hour. So we're going to be handling queries from the community, including yourselves. If you're in the audience and you have questions as we go, please feel free. So yeah, this is not just about doing a session of coding and everybody gets to watch. That's kind of happening in the background, but this is about me being available to the community, answering questions, and if you want to know anything, please feel free. So to get us started, I see we don't have any questions yet in the Office Hours channel. I think everybody's just getting their tweet alerts now, being alerted to that. So what I'm going to do is I'm going to start, and I'm going to try and keep an eye on chat at the same time. And I'm going to start looking at talking about the actual app that we're going to build today. Make sure I've got this all opened up on this side. So basically the idea, and I'm sure you saw from the title, is to build a search engine. Now, obviously, we're not going to be building any competitor to Google in a couple of days. The whole idea is to take the building an application and showing off kind of how you would think about doing that. Let me just turn do not disturb on. There we go. All right, so I do have a question. I'm going to go through this question quickly on serverless office hours. Somebody is asking, I'm getting API key already exists errors when I deploy. I have my API keys defined in the provider section as indicated in the documentation. I provide the key name value and assign it as a usage plan. Shouldn't it recognize that the name and value are the same and not error out? Okay, so this is somebody using API keys as a feature of API Gateway and getting an API key already exists errors. And this is an unfortunate little side effect of what happens with CloudFormation API Gateway in AWS, and there's actually a really easy solution. The first step is to remove your API keys and redeploy, so then it entirely removes them from API Gateway, and then add them back and redeploy again, and it'll add your API keys back. So I'm just going to go and comment that quickly to Larry in the Serverless Office Hours channel, so that he understands how to do that fix. I'm going to mute for the keyboard. All right, so we're back. Okay, so I'm going to switch to my other desktop, and we are going to, great, there we go. Everybody should be able to see my command line now, and let me just make sure I'm looking at the chat. The idea here is, like I said, we want to build a search engine, and the idea is to, this is a sort of an example project to take a look at how we would go about structuring a serverless application. How do you put the pieces together, you know, sort of multiple parts, you know, a front end, maybe a couple of additional services that do different things. How do we structure this? So really the idea here is that we are essentially going to have three parts to our search engine. The one part's obviously going to be a front end, and this is not necessarily going to be a front end discussion over the course of this week as we build this application. Really what we want to do is have a basic front end with a search bar. This is going to have an API query going forward that's going to do the search request and then display the results. A very, very simple little front end that's going to do an API call using JavaScript and return that into a div of some kind. Then we're probably going to have an API backend that we need to build to receive these search requests that goes and queries the data that we're going to build and display that to the user. And I think the really interesting part for me is going to be, we also want to build as a third part, we want to build a small, basically a very simple little spider, essentially, that can go and crawl web pages and pull out information from a web page to put into our search index, as it were. And to keep things simple, the plan is our search index is going to be nothing more than Dynamodb. But the idea isn't to demonstrate building a search engine to go compete with the likes of Google. It's just to show how a serverless application can be built and that you can go ahead and do these kinds of things relatively simply and easily. What you can see on the screen is, I'm just going to reply quickly to Larry. And what we're going to do is, I've already created a folder here called Serverless Search Engine where we're going to store all of our separate services in our front end. This is just in my projects directory, so there's nothing fancy there. I'm just going to use the serverless framework now to help me create the backends and the front end that I need. Awesome. The first thing I'm going to start off with is I'm actually going to start with the API backend, and that's just because that's probably the thing I'm like most comfortable doing. So let's relax things out a bit. Let's calm things down and build a simple API gateway service to receive search requests. So to start off with, I'm going to use my serverless command. And if you're not aware, I have serverless already installed. And just to set the context, I've done nothing at this point. Nothing has been set up or built in any way. This is straight from scratch with no previous work being done, with very minor research just to look at a couple of services we might be using, but that's it. This is also designed so that everybody can see how the thinking goes to building these things, which might be useful to see. Using the serverless command, I'm now going to bootstrap a brand new service, and I'm going to say, yes, I'm going to create a new one. This is going to be a Node.js backend. And what I'm going to call this one is, this is going to be the query service. And it's going to create the folder for me. And now it's going to ask if I want to connect to Serverless Framework Pro, which I do. I just want to check, do I have my browser set up for this? Yes, I do. So the only thing I've done as well ahead of time was I created an org in my Serverless Framework Pro account called Serverless Search Engine, just so we can keep things together. There's nothing fancy here. This is a product from Serverless Framework that can help me manage the development of my application and so on. If you go to dashboard.serverless.com, you can also sign up for this yourself. It has a free tier, so feel free to have fun with that one. But what I'm going to do is I'm going to connect my account to this. So back to my IDE. I'm going to say, yes, I want to enable this because I want to be able to troubleshoot through that. And I'm going to pick my Serverless Search Engine org here. And if I didn't have the org, I could create it as well. What I want to name this application so that my serverless search engine has no apps inside of it. I'm just going to call this search engine. Keep it nice and simple. And it should bootstrap everything. And would you like to set up command line tab completion? No, I don't need that. And there we go. I should now be set up. Awesome. So if I just do an ls here, you should see I've got this query service created for me. And I'm now going to drop into the IDE. So at this point as well, while we're looking at this, if anybody does have questions as we go, feel free to ask. Just bear in mind there is probably going to be like a 1-minute delay. So I see the internet man has suggested npx for serverless. You could. I don't see any problem with that. I haven't used it extensively myself, so feel free. Your mileage may vary. I don't see there being any problem because serverless is installed globally, usually with npm. If you can use npx and get it to work, feel free. I see no problem with that. All right. So all I've done is, and what I've done as well is, because my IDE is now opened up to the serverless search engine folder, that means, so if I do an ls here, all of my 3 services, my query service, my spider service that we're going to create at some point this week, and my front end are all going to be sitting in the same folder. And I could actually go ahead and push that folder into the same Git repository. So I could have a mono repo for my entire application. That's not required. And dog next door, if you can hear that. That's not required. You could have separate services and store each independently in a GitHub repo. It's up to you to decide that. But at this point, we're going to take a look at our query service, and we have a bootstrapped serverless.yaml file. So because of everything that I did in the command line, my service name's already set. The connection for the service to my Serverless Framework Pro account is already set. It's already got my Node.js 12.x set for me. And then it's got the basics already set, a function called hello handler, and the commented sections here. So I've got a reference to look at. I tend to like to structure my my folders slightly differently to the default. I'm going to go ahead here and just add a new directory. I'm going to call this source src to store my custom code that I'm going to be writing from scratch. And then I'm going to create another one called functions. But really, you can call this whatever you like. This is not required by any means. There's no specific structure you have to follow. This is entirely up to you and your team, how you like to structure your custom code. This is just the way that I tend to like to do it. What that also means is I don't need this hello handler here. So I'm actually going to remove that, and I'm going to remove this default handler. Actually, I'm going to leave it for now, just so I've got something to copy Bootstrap from. Here we go. Those functions. And I now can get started. So, thinking about my API. This is going to be a query point. So I need to be able to receive a post request with a search term in it. So let's think about creating a function for that. So I'm going to call this my query function. And this is going to be the handler. It's probably going to be, in the source folder, functions. And this is why I say that you can specify any path that you like to your handler, because you specify the actual path inside your handler function. And then I want the file name, so I'm going to call this query, and then the function name is also going to be query. Keep it nice and simple. The event that's going to trigger this is going to be an HTTP event. The path, I'm going to make this a v1. And I tend to like to version my API endpoints. And the reason for this is that I might at some point want a version 2 of my query endpoint. But I don't want to have to go force all the clients that are using my API potentially to go ahead and change. And that means that I might make a breaking change to a client that I haven't accommodated. So if I end up making a breaking change to the shape of my endpoint, that means that I'd rather just spin up a v2 of the endpoint. So that any clients can then optionally transition over. And then it's up to me to take as much time as I need with legacy clients to potentially switch them over to my v2 and deprecate v1 and get rid of it at some point. But that means I can take my time. I can push my v2 out, get everybody using the new version. Right now I'm going to go v1. I'm going to call this, I'm just going to call it query. And that's all I need. I'm going to make the method a post. Post, and cause is going to be true because I'm probably going to come from the browser. And that's really all I need right now. Yeah, I'm not going to worry about anything else. I just want to get something up and running. And let's get a basic handler out. So I'm just going to open up this handler so I can just copy this base code. So I've got something to work with. Create my new file, and I'm going to call this my query.js because I named it query here. I'm going to paste that code and change the function name here. So now I have a working function, and I can go ahead and delete this handler. Don't need this anymore. Alrighty, so get started. I now have an endpoint, and that's one of the cool things about serverless is that I now actually have a working endpoint. I could deploy this now and have a working function. I think I may end up doing that. And we're going to be using a new feature called Studio, which is why I wanted to connect to my Serverless Framework account. I'm just going to CD on my command line into my service that I'm generating. And I now want to do Serverless Studio. And this new feature, the Studio feature, is in beta at the moment. So we may come up across bugs. And what this is going to do is, and this is a very exciting feature that I'm really loving using, is that it's essentially going to give me a similar experience to using React development locally, where you have a dev mode that watches changes to your files. And when you save a change, it's going to refresh the browser so you can go and experiment with your changes. It's going to do something similar to my, and I may actually not have an AWS set up at the moment. Actually, I think it is. Okay, great. So what this is going to do is deploy my service that I built to AWS. And then once it's deployed initially in this initial section, it's then going to keep a watch on my files while I'm busy working. So The moment I edit one of my Lambda functions, this query.js file, it will then instantly deploy that to my stack that's sitting in AWS within seconds. So it's not like I'm doing another deploy that takes another couple of minutes. I'm busy testing out, and then in the browser, I'm going to have a very nice UI to deal with that. So let's go take a look at what that UI looks like in the meantime, because it should have some stuff running. If I go to Studio, give it a sec to refresh, and there we go. This is Studio sitting busy waiting for the deployment that I started to finish running, to allow me to start doing this testing, this back and forth testing that I was talking about. So let's just take a look at our deployment. Finish creating the stack. It's busy uploading all files that I need. Okay, now we just have to wait for the stack update, this initial stack update, which takes a minute or two. But as you can see, what Studio does, and it's already got some information about my function here, and it gives us essentially a Postman style interface. So after this deployments happen and it watches files, I can select this option and I can start passing it parameters in my body and post this into my actual function sitting in AWS itself. So unlike developing locally, where I might be trying to emulate stuff locally and it's not going to be as accurate as what is actually in the cloud, this is actually testing in AWS. So I know that the results here are what I can expect when I actually go into production, as opposed to doing everything on my local machine. Is not as good. So it's still busy. It's wrapping up deploying the stack at the moment. It's successfully deployed. It's now going to publish. It's going to start watching the files. If anybody has questions, now's the time. Alrighty. Right, so now it's busy watching my file for changes. So let's go to Studio and just take a look at what it's giving us. Now I could just post this. I'm going to, should log information already. Here we can see there's my invocation. My invocation happened. I'm going to click this invocation and take a look. This is the event object. So when we look at our code, you've not seen a Lambda function before. This is a Lambda function. Let's backtrack a little if there's anybody new. And what I've got here is I have an event object. So all Lambda functions are event-based. In this case, the event that's executing my code in the cloud is an HTTP event from an AWS service called API Gateway. And every event that triggers a Lambda function creates an event object. So you can see here, the event object is used here as a response, as my HTTP response, essentially through API Gateway. Now this object has a lot of data in it, and by default Studio is going to give me access to that data. I can just look at my event data here and go take a look at all the data available to me in editing my to take a look at what the object is that's passed to my Lambda function. Then I can look at the response that I sent back, and you can see there's my status code 200, and my body was the message go serverless, which is my function, and then the entire event object. So let's just go edit that quickly. We're going to make a quick change here. I want this to be the body, so event.body only. When I save the file, you can see it's redeploying just the function, which should only take a few seconds. There we go. A function is now updated in Studio, which means if I test it now, this should look different. If I send again, I have another invocation that just happened. There it is. Our response is now much smaller. Ta-da! Oh, input. Oh, because it didn't pass the body. You can see this is now I'm locally testing in the cloud. Pretty awesome, I think. Let's just actually go fix the code. So it's what are the pass the body so that I can actually get some data out. So test. Yeah. Test, come on. And there we go. Send that as my request. I have another invocation here. And response, cool. There's my body coming back to me. Awesome, so that works. Just to cover a couple other things that you might see here as well, you can see because I'm in Serverless Framework Pro, which is a monitoring platform as well, my invocations here, the previous ones I sent, actually show me some metrics, some running details, some execution details. Yeah, so I can see, for example, I have the amount of memory that this function used, the latency, so how long it took to execute because of cold start, and the actual duration. So here we can see here's the function invocation, how long it took to function. So some pretty useful stats here. Yeah, and this one here ran a bit faster because it was second. And yes, you can. There is no logs because I'm actually not logging anything, but let's make that change. Sorry, Amit was asking, can we check function logs in Studio? And yes, you can. So let me actually go take a look at the code again. And instead of this, let's just do a log. Let's log out. I am here. So if you were logging out some data as a part of your function, I'm going to save that. It's going to deploy it in a few seconds to my live stack in the cloud. And then I can test it in Studio. There we go. Now if I send that test request, my log should show up here. There we go. There's my log showing up. Pretty awesome. This should also, I believe, there's been a recent change here that this should show errors. It returns an error. Let me actually go ahead and test that. Why not? I didn't realize the stream was going to turn into a stream about Studio. But I'm happy because Studio, in my opinion, is a very awesome addition to Serverless Framework. So let me return a new error. I am an error. You know, if your Lambda function errors out or something like that. Let's deploy to the cloud. Okay, and if I do another test. See, there we go. It does actually bring the error out. That is actually wicked. That's awesome. This is a recent change because it never used to show errors, but now the Studio is really coming on leaps and bounds. And I'm quite happy to see these changes coming. So here we've got my error. I've got the log that I logged out. Pretty awesome. Okay. So enough showing off the Studio, I guess. This is basically our dev tool that we're going to be using back and forth with our code. But now we need to make some structural changes because we're going to need, for example, a Dynamodb table. So let's go ahead and add that. And we need to make something that's generic enough to handle our... I've got a very vague idea of what I want as far as the structure for our Dynamodb table. So let me uncomment this resources line and this one. Make sure it's indented correctly. And we're going to call this our keywords table, because this is where we're going to store our very basic keyword information about a site we might crawl with our spider. And the keyword and the structure that this is. And so this is how I normally go about doing my Dynamodb table. So I don't remember all of the stuff from scratch. Actually, I'm bring my bookmarks toolbar back now. I go to the CloudFormation documentation for Dynamodb. And it's not as scary as it sounds, honestly. And what you see here is if I scroll down to the YAML section, I'll see, okay, here's some attributes that I need to apply. I need to apply some of them, not all of them. I'm going to go, I need to apply this one to say that I'm using I have a Dynamodb table. Let's go ahead and add that. I then need to add a properties parameter, like that. And I do know, so if I scroll down here, I can see attribute definitions. This is required depending on what I find. So I do need attribute definitions. So I'm going to add that in. If I want to see what those look like, I go to the definition here and I can see this attribute name and type. And this is an array, so attribute name. And this I'm going to call, okay, so this is my primary key. So we could also go in a very long discussion about Dynamodb and how it works, but the basics that we're going to do here is a sort of single table type structure using multiple keywords. And I'm going to go into a bit more description about that once I lay this out. But we're going to have a primary key and a sort key for our Dynamodb table, which is how you query your Dynamodb table. And what's going to end up happening is that every collection of, every possible combination up to 3 of search words is what we're going to potentially filter by. So what I mean by that is, so let me just write this out so we can take a look and see what I'm talking about. So first of all, I'm just going to call this, this column a PK, and the attribute type for it is going to be, I just need to indent that correctly. That's going to be a string. So that's going to be my primary key. And then I need to do the same again, but this time for my sort key. So I'm going to make that an SK. And this is my secondary key. So with Dynamodb, I can query on my primary key and my secondary key as sort of a filter on the primary key as well. And the idea is that I want to do, let me just do a demonstration. So our very basic search engine is going to do something like up to 3-word search. Very simple. If I want to search for serverless framework awesome, for example, if that's what I ended up typing in my search box, we're going to search for the primary key to have the word serverless, my secondary key to have the word framework separated by a pipe, probably something like that, and the word awesome in our query. And any website that we happen to use our spider on that sees serverless framework awesome together as 3 words is going to store this in all these combinations. So we'll have serverless framework awesome, we'll have framework. Actually, no. The idea is we store it like this because this gives us a way to search across those 3. The idea here is that when somebody searches for serverless framework awesome, this will be the 100% hit. If they search for serverless awesome framework, it's not going to hit. It's not going to necessarily hit this as this isn't going to be the top result, but it would still find this because we're going to take the search terms and query. So we're going to end up querying on something like serverless as a primary key with starting with framework awesome, and then we're going to do another search for serverless. Oops, I'm going to do this and awesome framework, and so on and so on. And then we're going to swap these out for awesome serverless, and so on and so on. That's the idea, is that the query is going to be a 3-word search, and we're going to arrange the 3 words, nice and simple. Nothing too super complicated. You'll see eventually when we get to the spider and the search parameters. But yeah, that's the idea. So setting up Dynamodb is actually very simple. I've got two column names. I don't want to specify any other names. I don't need them. And that's all I need for my attribute definitions. If I now go back to the root of this, I don't need global secondary indexes. I do need billing mode. I'm going to set my billing mode right now, and this is going to be, I have a couple of options. Let's click through. Pay per request. Let's just keep things simple for ourselves. Pay per request means that I get billed on usage. So if I only have 1 search a month, I'm only going to pay for that like less than a cent for that 1 search, which is pretty cool. And if I go back to the main screen, and I don't need global secondary indexes, I need a key schema. So I'm going to drop my key schema in to specify that each of them is what they are. Let's click through to see the structure of the key schema, and their attribute name and key type. That's pretty easy. So right now, this is an array with an attribute name of pk, and the key type here is hash. And then I have the attribute name of an SK. So my SK column is a key type. I just want to make sure I get the exact range. I would have gotten that wrong. Right. And if I go back, I think that actually is all I need to set up my table. Let's go take a look. I've got my key schema. I don't need provision throughput. Table name. I'm going to use table name. So I don't have to specify table name. If I don't, it'll be automatically generated for me and sort of randomized. But I like the idea of creating my own. So I also end up creating a table name that's now namespaced to my service that I'm busy building, as well as the stage that it's going to deploy to. So if you're not familiar with the serverless framework, you can deploy into stages. And by default, when I'm deploying through Studio like this, it's using the dev stage. But I can set a stage as the environment that I'm deploying into. So what I'm going to do is I'm going to preface this with my service name to begin with. Then maybe I'm going to use the keywords table, so I know this is the keywords table. And then I'm going to wrap it up with opt stage. And just in case a stage isn't passed, I'm going to make sure I pass something as a default like dev, make sure that it's not going to error out. And in this way, if I'm developing and deploying this into my own AWS account multiple times, it's not going to conflict. I'm not going to overwrite someone else's or get an error because someone else has created a Dynamodb table with the same name. Pretty useful that way. And that's really all I need. And for Studio to work now, I need to actually close Studio off and then do another deployment from scratch. So Studio should now be closed. Going to redeploy. Use the serverless studio command. So because I made changes to the serverless.yaml file, this is going to make changes to the underlying stack. So therefore, it needs to redeploy the entire stack to push those changes through. So whilst redeploying that, let's go take a look at our query file here. All right, so we have a Dynamodb table that's been deployed. I just realized I need to add IAM permissions. We'll look at that in a second. All right. And again, if anybody has any questions, please feel free to ask. All right, so obviously I don't need all of this. This is not what I'm going to need for my query. What I am going to need is a way to read the body of my query. So let's start with that. Let's get the body out of my event object. And I'm going to parse it immediately from the event object like so. The event object has a parameter called body, which is going to be my JSON. I'm going to parse it out so that I get an object in my body variable here. Obviously, I don't need that error. And at this point, this is where I'm going to build my query. And for now, we're going to keep this query simple. We're not going to try all the permutations. We're just going to make sure we can query our database as we need. So that means we need to create a query parameters object so we can build our query. And this is where Dynamodb is also different to a relational database in that we build a query as an object as opposed to SQL. There's no SQL for Dynamodb, which is, in my opinion, pretty cool. I'm not the biggest fan of SQL, to be perfectly honest. So what we're going to do is start off with, we need to say table name. And if anybody wants to know how to do this, it's actually a pretty simple process. Again, if I go to some documentation, the Dynamodb document client documentation, and I'm going to go find the query parameter here. And here is an example of a query. It's actually very simple to do. I'm going to start with the table name. Go ahead and do that. And with my table name, this table name is going to be available to my Lambda function as an environment variable, which we'll set up in a minute. But I'm going to assume that my environment variable is going to be called Dynamodb keyword table. That way, it's going to use whatever's the environment variable called keyword table for that. If I go look at my documentation, I now need an index name. Actually, I might not need to use query because I'm going to use query. There's another option here called get. So if you were just querying by the primary key and not filtering out by the secondary key, you could just use the get option here. We're not. We're actually going to use secondary key. So I do need to make a query. The index here, the index name, name is going to be PK. That's my main index. I don't have any secondary indexes. And then my key condition expression is basically how am I filtering this? What is my filter criteria? So I'm just going to take this as a way to show this. But my hash key, for example, is going to be that. And then I want to filter by, so the body, okay, this is going to be the secondary key. So let's just make this, let's make this range key and R key, so that's fine, is equal. Actually, I need to, so I'm going to say equal. And this R key is going to be a combination of the two words. So this means now we need to break down our text that is being submitted in the body. In the body, what's going to happen is we are going to have our keywords is going to be body.string. So we're going to have an object called, actually let me just call this search. So we have a string called, a property called search with a string that's going to be the keywords submitted as part of the search query. And let's just split that into an array so that we have an easier way to manage that. Split by space. Yeah, So the keywords will be separated by space, and it's going to redeploy now because I saved my file. Not a problem though. All right, so we have that split. So that means we have an array here, and we need to build a string for this R key. So I'm now going to say the const, this is going to be my secondary key, is going to be keywords array 0 and keywords array 1 together. No, sorry, 1 and 2. Yeah. You're going to remember the first keyword is going to search on the primary key. The other two is going to search on the secondary key together, separated actually by a pipe like that, because that's how we're going to add them to the database. So there we go. There we have secondary key. Right, so now that I have this sorted, I can finish my query here, because I now need to set my expression attribute values. I want to set the values for these parameters here. That's done using expression attribute values. I'm going to say h key is going to be equal to keywords 0, the first keyword. And then I'm going to have R key here is going to be equivalent to my secondary key that I built over there. And finally, I just need to do the names. So expression attribute names is these here, hash key and range key. That should be a hash, right? And that means I can do that. We're just parameterizing our query so that we have less chance of a SQL injection style attack. Similar thing as you do in, I mean, I say SQL injection, but anywhere that you can accept user input that can then be run into any kind of data store can potentially be a security risk, an injection style security risk. So in this way, we're parameterizing it so that it doesn't, it can't be used that way. So I just need to grab hash key, and that's going to be PK because that's our primary column name. And then we need range key here. And that's going to be SK. Alrighty, so we have that query parameter done. We now need to say let query result equal to this, and then I like to use a try catch block for my queries. This is just standard practice, something that I tend to do. It's funky. Come on, there we go. And then I will log out. There was an error here in the database, and then I will log out. And I like to log out a lot of information, especially when I'm developing, because the logs are available in CloudWatch, but they won't be available if you don't actually log them out. So makes sense. Log out as much as you can, especially while you're developing. Maybe you come in later and you turn some of them off. There are ways to use like a dev mode so that you'll only log them out when you're in a dev environment. You could potentially do those kinds of things using an environment variable, for example. I'm keeping things kind of simple here for now. So my query error, and then I also would want to see the query params are passed as a way to debug. So let me just put that here. And the reason I put the string here so that I know what comes after is this variable name. It's just a way for me to keep track of that. And then ultimately I have to return a new error, and I'm just going to copy this text. This error goes back to the client making the request, and they'll get a 500 error saying there was an error. And then here, now this is assumed, this is to catch any potential errors we have, which we are going to have if I don't add the IAM permissions in a minute. But let's add a query result. And I now need to add AWS SDK. So now I need to actually talk to AWS from my Lambda function. And this is where I'm going to go hop into my other CLI here so that I don't interrupt my watch. I'm going to go to my query service, just like we were before, just like we were seeing before. And I'm going to add the AWS SDK here. So npm I save, I actually save this as a dev dependency because the AWS SDK is available in the Lambda function always. You don't have to deploy it with your Lambda function. That looks good. I'm going to wait for that to be installed, and then I can use that inside my Lambda function. So let's just const AWS, and we require the AWS SDK. Alrighty. So now I can use the AWS SDK, and first thing I want to do is I need to create a Dynamodb object, new aws.dynamodb.document client. And I like to use the document client variant because it keeps things a little bit simpler, which is quite nice. Get a new instance of that. You can see my ID is busy fixing the AWS SDK. It's a bit of a beast. All right, now that I've got that, I can run my query result is equal to an await on dynamodb.query. I'm going to pass my query parameters and return a promise because the await is going. So this should run my query, run all of these parameters that I have now set, and that should be it. I now need to go through the queries and just extract the actual data from it. So I'm going to let query result equal. Oh no, no. So response is equal to query result dot map, and I'm just going to go and extract the data of each item. Query result dot items. So when you get the result, it returns a dot items object from DynamoDB. I'm going to map that, so that's going to be result item. And return. Okay. I'm actually just going to return the item for now. I might refine that later, but this just gives me the ability to refine that later. All right. So now that I'm returning that item and everything on the stream seems to be running fine. Good. Again, if anybody has come along and you have questions at any time, feel free to just leap in and ask a question. I can even backtrack to show anything if you. Okay, I'm going to result item. Cool. Result item is being returned. This means I need to change all of this, obviously. So I'm going to remove all of this. None of this is needed, and I just return my response object there. That should do it. You can see here it's busy redeploying my changes to my function, so I can test that in Studio. So let's take a look at Studio again. And I'm going to run my function one more time, and this time I have an actual structure that I'd like to adhere to based on my code I've written. Let me go take a look at the code. I've forgotten what I set that as search. So I have a property called search, and this is the search term that's going to be submitted by my search engine serverless framework. Awesome. And I'm expecting this to actually error out. So let's clear the other logs that were there before. Let's send this data. Expecting a nice big fat error because missing required parameter table name. So first of all, I don't have my environment variable set yet, which we're going to do now. And I also need to set my IAM permissions. Great stuff. So let's go back to the code and my serverless.yaml. I'm just going to now. I'm going to go back up to where, and I tend to like to keep these things where the environment variable is, for example. So I'm going, or where it's defined in the comments. So I'm going to go to the environment section, and this file, this variable is called Dynamo keyword table. Let's just do that, and it's going to be equal to the table name that I gave. So bring that up. There we go. Now I've got the name set here. So that's going to resolve. The only downside is now because I changed that. Well, let me do the IAM permissions, but I'm going to have to redeploy my stack. But let's add my IAM role statements now. So I need to set IAM that. I need to give my Lambda function access to Dynamodb. By default, Lambda functions don't have access to anything, which is a pretty great security posture. It's a good thing. But now I need to actually give my Lambda function access to my Dynamodb table so that it can actually query it. So this is done by just setting a IAM role statement like this. So I'm going to give it the effect of allowing access to the action, and I believe it's Dynamodb query. And in the errors, if you didn't have it set correctly, in your errors, you will see the actual error will tell you what is missing. Harsh Thakur asks, will this code be available on GitHub? Yep, I'll stick it on GitHub. I will post that in I'll post that in the description of this video once it's gone up on YouTube. If you're watching, you can just look in the description and you should see the URL for the GitHub repo in the description. Right. I've got my action set. It's going to allow me to do a Dynamodb query, but now we need to tell it which Dynamodb table to do that on. And I want this to be on the ARN, AWS, and I'm trying to remember, this is going to be Dynamodb. And usually, and this is not going to make much sense right now, but will in a second, you have a AWS region will go here. And then following that will be the AWS account ID. And then it'll be table, if I remember correctly. And what I'm going to do is just off screen quickly, I'm just going to take a look at my AWS account. All right, one question. David Ensat has a quick question. Although AWS Sdk added as a dev dependency, the function uploaded to AWS increased 121 kilobytes to almost 9 megs. This expected. Okay. If I was doing an exclude, setting up individual packaging, I could exclude this from the bundle that goes up. But you bring up an interesting point. It's 9 megs now. In my opinion, there isn't really any reason to worry about that size so much, apart from maybe it taking a little bit longer to upload into AWS when you're deploying. I have not really found there to be much impact on cold start times. Some people do say that there is. I just haven't seen it myself. To any large degree, I'm sure that if you do reach a massive size, it's going to affect it by a few microseconds at the very least. But I haven't seen enough justification to go through the process of setting up the individual deploys with some kind of packaging plugin as well and stuff like that. That's just my opinion. So ultimately, I'm not too bothered by that. When it comes down to it, before you deploy to production, you could actually end up removing that from your package.json anyway. Ultimately, that doesn't really matter. Okay, so I'm just going to take a look at the ARN for this table so I can remind myself what those look like. And I'm just going to my AWS account and I'm going to grab take a look at that ARN. And obviously I'm doing this off camera because it's... If you have any questions, feel free to drop that into the chat right now. If you disagree with me, feel free to say why. I could be wrong. And I'm going to... And tables. And this is going to... What by name? Query service. Okay, so there is the... I don't have the exact one. All right, now I see it's region, table, and then my table name. So it'll end up being that, and then my table name, which I have here. I'm going to bring this across so that I don't want to put any wildcards. The reason I do this, I want the actual region is being deployed to, the actual AWS account ID that's being deployed to, and the actual table name. You could just put a star here. And while that will work, that's not exactly the greatest idea. That is a very insecure way of doing that. You want to try and be very specific with the resource and the actions that you can. It's just a very good security posture to have in general. So you may have seen these funny flags here. This is because I like to use a certain plugin that helps me get these variables nice and easily. I've always found that trying to use the CloudFormation way of retrieving region and account ID variables is always a bit iffy. But there's a really nice plugin called Sudo Parameters plugin, which I'm going to use for this. And you can use the serverless framework to install plugins. So I'm just going to go serverless plugin install name, and this is the serverless sudo parameters. Actually forgotten if it's sudo serverless parameters plugin. Let's just do a quick Google search. Sudo parameters. No, it's not. Okay. Isn't? No, it's not. Okay. We're running that. It's the serverless plugin. The serverless framework is now going to install the plugin for me, do everything I need to do, set up the reference in my serverless.yaml file, get npm all initted and set up and what have you. And now this should work. Now, studio again. I shouldn't have errors that come with this. And you can see if I go to the end of there's my plugin reference. Right, so that's busy now deploying again so we can start Studio up. If anybody has a question, now is the time to grab that, and I'm just going to have a little sip of something to drink because my throat is getting a little... So as you can see here in general, creating a serverless service is very similar almost every single time you do it. If you've ever done a serverless API, this is a very similar setup here. Just because we are doing something interesting like a search query or something like that, ultimately doesn't change the fact that we have an API gateway endpoint running a Lambda function. The interesting bit comes in the small bit of code, and even this isn't that complicated yet. This could potentially do something far more complicated. And in our simple example here, we're going to be using Dynamodb as our database for our search queries, for our little search engine, because it's a very limited example. But ultimately, with these pieces, with these multiple services we're building, you could go ahead and create a separate way to build this as a backend. Which means you could have a Elasticsearch backend, an Algolia search backend, if you like. Whatever is appropriate to you and the solution you want to build. So the interfaces to your front end, for example, don't have to change, but your backend can change. And because we are, and I'm actually going to do this now while this is deploying, I'm actually going to just pull up this other CLI here. Let's clear this. Let's maybe make this a bit bigger so everybody can see this. And if I back this now, you can see I've got Serverless Search Engine is my project name. Query Service is my one microservice. So let's just make dir. And I'm going to make this front end. So now if I ls this, now I've got two of my three-part service sort of just specified in my directory. And if I do another, I'm going to make this my spider service. So now I have a combination of these three services. And by separating these out as separate services in separate domains, the query service doesn't care how my search engine data is generated, how it's built, how it's queried, how it's extracted from the web. The spider service does that all on its own and has no impact on the query service. The query service is just going to look at the actual data. And ultimately, over the next, and if anybody's not aware, this is a project that's going to be built over the course of the week. Tomorrow, we're probably going to go build the front end portion to the query service. And then the last session is going to be the actual spider service that's going to go query and pull data from websites and so on. So this and all of these videos will be on YouTube as well in case you can't make the live stream, because tomorrow's is going to be at 10 a.m. GMT at the same time as the serverless office hours for the European crowd. So we are going to basically wrap up as much of the query service tonight as we can, and then do the front end service, which is going to be a very simple thing. You're not coming for the front end, trust me. Front end part is going to be a very simple vanilla HTML and JavaScript piece. The best part about the front end thing, the front end portion, is to show you how to deploy a front end into S3, CloudFront, and so on, and then the Spider service. Behind the scenes, that's going to be building our data set for us. Alrighty. Now that we're watching changes here, we have what should be a working query now. It just has no data. So let's go ahead and look at Studio again, and we have our little Studio here. And I'm going to use another feature here. I'm actually going to save this event as a test event. And I'm going to do a search is my parameter, and serverless framework. Awesome. Send, and I should have no errors, but I should also have no results because I don't have anything in my database. Okay, so there was an error. Value pk at index name failed to set it. Not need index name because I'm using the primary key. So let's go back and fix my query here. I can actually remove that, probably. Studio is going to allow me to redeploy my Lambda function, the code, within a few seconds so that I can retest it back in the cloud so that I don't have to do that whole couple of minutes of deployment time. There we go. Let's run it again. I'm actually going to clear this log so I can see one coming up. There we go. Response is not defined. Okay, so this is a different error. This is how we debug. And this is the great thing. I'm now debugging in the cloud using Studio. I love this so much. Thank goodness. So this is on line 38. I am not referencing. Oh, because I defined it in this block here. So I'm actually going to change this to be response, change this to be a const because I don't need it outside. And then I can remove that. That should work now. We can see he's liking it as well. Wait for the few seconds of deployment time to pass. Okay, and test again. Awesome. I actually have nothing there. I have a response. Let's check my response 200, and my body's empty because I have no data in my database. Yay! So what I'm going to do is I'm actually going to add some data into my table quickly just to finish the test, and I'm going to say create item. PK is going to be serverless. The SK is going to be framework pipe. Awesome. Save. Okay, and hopefully this works. Run that query now. Should see response. That didn't work. Now I'm going to have to go and debug this to see why this. So, time to go do some logs. See what I did get out of this response. So let's just log my query result here. And let it update. Okay. I am returning 0 items, so I think there might be something wrong in my table. It does not like how I've structured it. So let's go up and look at my parameters. I should have actually logged that out as well. That would make sense. Let's log out query parameters too, so I can see what it is I'm actually sending. Make sure I've built that correctly. As you can see, this is the process. This is the dev process as you would normally have seen in your local environment. You know, prior to serverless, if you build serverless applications, you know that deploying to the cloud can sometimes be slow and annoying, but Studio's got my query here. I can see so my for some reason it's just saying right, so it's putting just the first character out. That's why. Okay, so let's go take a look at the code, make sure where I That's why I need keywords. That's the problem. I need that, not keywords. Yeah, I was pulling the entire search phrase and then was only grabbing the S in the front of it because I said 0. That should fix it. Save my file. Watch it redeploy quickly, and then we can run the test again in Studio, and that should fix the problem. Cool, and that means test again. Now we should. Yes, now we got a result. That's awesome. That means that my response here should have peak. That is pretty awesome. I'm pretty happy with that. So what this means is that now we can start adding some additional structure to our Dynamodb table, because what we should expect, and I'm going to edit my Dynamodb table here to have an additional column. I'm going to add, I know you can't see this, I'm just doing this off screen because this is in my AWS account, but I'm going to add a field called URL, and this is going to be serverless.com. Because when you're doing a query, like a search engine query, you just want the URL of the site that it came from. So let me fix that. Serverless.com, save. And in our code, what I mean is in our code, you should be able to just pull out. You don't want the entire result item. You just want URL. That means however our data gets added to our Dynamodb table, it must always have a URL string. And I can't do that, right? Does let me look in Studio quick to make yeah, so this has the column list in the item. All right, so that'll be fine. So let me go and save that in my IDE. Okay, it's redeployed already because this saves automatically when it loses focus. Go back here and yeah, the logs again, and I should just get the URL out now as response here. Let's see. Go, that's the serverless.com. Awesome, I'm so pleased. Okay, so this is at a very basic level, it's working. It's searching our Dynamodb table for the phrase serverless framework awesome using the primary key and the secondary key, and it's returned that result as the API. Nice. All right, so now to move on a bit, we are going to take a look at setting up the spider service, and I think we can take a little bit more time to do this. It is getting on a bit now for this stream. I think a lot of what we want to do next for this specific service with the query is, okay, so one of the things we want to do, and this is where I think it becomes a bit more interesting now, is that if we have a separate spider service here, the spider service is what is going to go trawling the web looking for, hello Defiance, the spider service is what is going to go trawling the web looking for websites and indexing them for our search result. But we don't want the spider service, and this is a principle of microservices, keeping them separate with separate data sources as well. We want our query service to query the Dynamodb table, but we don't want the spider service to be working on that Dynamodb table directly. But we do want the query service to be able to update the Dynamodb table. So what that means, I go back to the CLI, we need to add a new function. And this function is going to work through SNS. And I'm going to use SNS because it's what I'm familiar with. You could use EventBridge potentially for this, but we're going to say add keywords. So this is going to add entries into our table, and I'm going to make this a handler called source functions. I'm going to name it keywords. The events that it's going to get triggered by is going to be SNS. And now I'm going to assume, okay, so I'm going to use a new feature, a feature of Serverless Framework Pro called outputs. So the query service, the spider service that is going to go scan for all our data is going to be pushing the sort of keyword entries into the SNS topic. And the query service is going to read that and build that into its Dynamodb table. So I don't want to specify a new SNS service. I'm going to specify an existing SNS service potentially. So what I want to do is use outputs. So outputs is a feature that I can use in my Spider Service. I'm actually not going to add an event here initially, and we'll comment that out in a minute. The reason why is because I need the Spider Service to exist and have created the SNS topic so that I can use it here. But let's just assume that that's happened. And I'm going to use outputs. So let me just put this out. Outputs. The service name is going to be in the same. So I'm just going to say this is going to be the Spider Service. And that is dot the keywords topic. Okay. What's going to end up happening is that when I create the SNS topic in the Spider Service later this week, I'm going to have a section in the serverless.yaml file for the Spider Service that uses outputs. And one of those outputs is going to be called keywords topic. And that's going to be the ARN, or the topic name for the, no, I need the ARN. So it's going to be the ARN, AWS, SNS, and so on and so on and so on of this of the topic that's created. What this is going to do is it's going to create the value, set the value of keywords topic in Serverless Framework Pro, and on deployment time this is going to get read into here. So for now I'm going to leave this empty. I'm going to comment out this event because I don't need this, and this is just for demo purposes. I'm going to remove that. But we now have a new function called add keywords. So I'm going to add a new function here. Functions file called add keywords.js. I'm going to create the new function. Async event. And yeah, so this is going to receive an event object from SNS. And if you want to see what an SNS event object looks like, you know, going to look here. You can really just do a Google search for SNS event object using AWS Lambda with Amazon SNS. Usually the top result, and here it is. Here's an example of what the event object will look like that comes from SNS. So you can see there might be multiple records separated by SNS with the message there. So this is where my message is going to be. So I just need to access that. So let's go back to my IDE, and let's do a const for messages is equal to event this to be event records dot map, and I want each let's call it record, and this is going to return object. Actually, yes, no, it's just going to return the actual message. So it's going to JSON parse the record. So each individual record, let's go take a look at the structure again. Each individual record is in SNS. So let's go dot SNS there, and then it's going to be in message. So dot message, and that will be JSON. So that should work. Okay, it's going. All right, so now I have my message and I want to import this in. I'm going to, oh, and if anybody new has come along and has questions, please feel free to ask questions. And we are doing office hours on the Slack, the community Slack. So I see there is a question from Andrew Blair. Okay. So Andrew Blair is asking about components, and if anybody's heard about components, it's a new feature that a new how can I put it? A new way to do serverless application development that the serverless framework team is busy building at the moment. And Andrew Blair asks about the serverless Next.js component. All I can say, and I'm going to answer in text to Andrew as well, but all I can say is that the team is busy working on it. There is no definitive ETA on that yet. I do know there has been discussion about doing the newer version of the serverless Next.js component. The component released last year that happened was a sort of beta version, so that we could get feedback from the community about what this looks like, what it feels like to work with components. And about a month ago or so, we actually just mute out so you don't hear the keyboard. Okay, so let's carry on. So again, if anybody has questions, feel free to ask. This is what this is all about. We're sort of relaxing, building a serverless application, answering any questions you have about serverless. Doesn't matter what the question is. Feel free to drop that into the chat. As we go, I'll be answering questions. Right, so the idea here is that this function is going to receive keywords from our Spider service to add to the Dynamodb table. So now we need to add these individual messages as entries into our Dynamodb table. And what this is going to look like, what I'm expecting these messages to look like, is something along the lines of, you think about this for a second. Let's just keep it simple. We can always come back and rework this later. So there's going to be a keywords section. And this is going to contain something like serverless framework. Awesome. And it's going to also contain the URL, something like serverless.com. I just realized there's a potential issue with what I did before with this, because I'm going to need this URL to be a array, because there might be multiple URLs that match that key. Okay, that actually helps us with our queries. All right, so I just need to bear that in mind. Okay. All right, so looking at this, I'm just going to comment this out so that it doesn't interfere with our code, but it's there as an example. So this is going to end up being an array. Let me just finish that off. So that, okay, great stuff. So serverless.com. Okay, the messages might potentially contain many. So let's create our put params. We need to put data into the database, into the table rather. Yep, same thing. Table name, once again, is going to be our environment variable. Let's go grab that. Process.env.dynamodb table name and item. So this gets very simple. Item is going to be that, and it needs to be right. If we have this structure, we're going to need to break this down a bit to fit the way we've designed it. Oh damn it, I'm seeing there's that bit of a flicker there. I know how to fix that. And that should be better now. Okay. So what we need to do is we need to split this according to our primary key and our secondary keys. I'm just going to go here and just grab what we did here. I know this is a bit wordy, but I deliberately made it very verbose like this so everybody can see what's going on. So really I want to grab all of this there. And I'm going to do I'll look this up. I might actually not build this in. We're looping through, so we might as well just do everything we need to here. So I'm going to grab this. I'm going to put this in here because we want to grab this. I'm going to, yeah, I'm not going to, I'm going to do a for each here to loop through, and we don't even need to assign that anywhere. We just want to loop through all the records and leave the message is that, and let's just grab the code from here to then break that up. Message dot keywords split, and that should work. So the item will then be PK is going to be keywords array 0, and SK is going to be key. To do that, I don't need a return. And we are now going to try catch block. And this is going to catch and put error. So if we do have an error putting into our Dynamodb table, I need to add AWS. So let's just add that quickly. Require AWS SDK. Oh. Okay, and that means I now can do a const. Actually, what I'm going to do is create this once outside so I don't recreate it every loop. Potentially, let's optimize a little bit. Dynamodb is equal to a new AWS dot Dynamo document. Oops. If you're wondering why I type out like this, is because the microphone's slightly in the way of the keyboard. All right. Right. And let's use Dynamodb now in our try catch block. We just want to run it. We don't need to necessarily do anything. This is off of SNS. Actually, funny enough, we don't even want to do a try catch block. We want to potentially repeat this. So here's something else to remember about using these events like SNS. SNS has a lot of error management built in for you. You don't necessarily need to do a lot of error management yourself, because this function is going to receive stuff from SNS. If this function returns an error, SNS is going to do retries for us. And we will see these errors in Serverless Framework Pro, for example. So we will be able to monitor this to see if there are errors because we make an error in code. And ultimately, these things are going to retry and get built anyway. In this case as well, being potentially adding the same item multiple times doesn't matter. This doesn't matter for our use case. Our data model doesn't care about the same item being added multiple times, thankfully. And potentially being an index for a search engine, if we happen to have an error, skip something, or miss having keywords added, not a big deal. It'll potentially be rescanned at a later date. Pretty useful. So this is a very forgiving data model we have here. So we don't have to go crazy trying to make sure we use the right service for the right error management. SNS is perfectly fine. SNS retries 3 times with progressive backoff, which is fine for our use case. If there was a very simple or a very transitory error that happens, the retries will catch that. That's pretty awesome. So let's just use that. If there's an error actually putting, it'll throw an error and SNS will retry. So let's not worry about it. So I'm not going to use a try-catch block because that just adds complexity. Let's just use the Dynamodb object we created here. Let's await the Dynamodb object to do its put on our put params and return a promise. Otherwise, the async wait will not work. And it's telling me there's an error, so my error. Actually, I don't even need that. Actually. Yeah, I don't even need to wait for that because it'll just process them all. In fact, there's normally only ever one. SNS, I have yet to see an SNS actually return more than one, add more than one record at a time. But you know, we have to manage that use case just in case. And that should pretty much do it. And then ultimately you can just return true. And I'm just going to do that in here. Yeah, just do it, so that's fine. Alrighty, so this has been updating the entire time we've been saving. Good, updated. And what this means is, so the test here now with Studio, what's nice is I can actually test a function. I'm going to add Studio back to the screen here. What this means is I can also test my add keywords and pass an event object myself to trigger manually. So we can go to this one. And the problem is I think that is JSON, and we'll just test that out. And the plan is ultimately with Studio to have support for other events like SNS, for example, SQS, and probably a few others. And here I want the message to be JSON to object conversion. I know they're out there. I just want to convert this JSON object. Here we go, JSON literal into the JavaScript literal object. That means I can now add my message in here, which can be JSON. So that can be the structure that we had. We can take a look here. This needs to be keywords and URL as, let me grab this exactly as, drop this in here as the message. And clean this up. To be there, and that should be testable now. And see, all right, let's run a test. We're probably gonna have errors here. Right, can't read properly. Find. Okay, so we do have an error. The for each doesn't like what it's getting. It's probably because my event object is invalid. Let's go take a look at logging that out a bit. Alrighty. So here, and here you can see I'm also getting logs. I read. So the errors are actually coming through. This is an awesome new addition to Studio. This is actually coming through from the logs because we're watching for changes. I'm actually getting the error log from my SNS coming through to my CLI. Actually pretty neat. So that was already in. That's a nice addition. Okay, now what I'm going to do is I need to log out what this object looks like. It doesn't like that. Let's just log out the event object. All right, let's let it redeploy that. A couple of seconds. And up, let's go that log and test. Yeah. The event object, it's there, right? Yeah, I think I may be wrong. May actually be sending event object. No, it's an object. So it's being this actually being valid object. Closing pieces it needs. Okay, so at this point, I'm actually going to leave this portion to be tested when we have an SNS event source that we can trigger this from. Because it looks like I'm not building the event object correctly for the SNS. So I may just be getting this wrong. There might be something very simple here that I'm not getting right. I'm not entirely sure why it is doing that. Let's record. I think it's seeing it as a string for some. Oh, it might be Studio's actually passing it as a string, not an object. There's the problem. Okay. Take a look at Studio. Yes, I think that is what's happening. So there we go. We found a bug in Studio. It looks like it's sending this as a string and not converting this to the object that it should. That is, yeah, okay. That is the problem. And I can't think of any way offhand to just do that now. Okay, so let's test that another time. Great. So because we've basically gotten all the pieces we can for now done for our query engine, where we're actually being able to query for keywords, we created a endpoint, function endpoint, to receive keywords through a post request. And we created a function, at least in theory, that's going to receive keywords via SNS object. We've just commented that out so that it can deploy without the SNS object actually being created. This service, for all intents and purposes, is done up to now because we are still experimenting with how we're going to do this with the next service that we're going to build, the spider service that's actually going to go out and trawl the web, read off the pages that we're querying and so on, and index it for us. And that will probably be creating on Thursday. Tomorrow we're going to go and look at doing some front-end work. We're going to create a very basic front-end with a Google-style single input box that's going to accept up to 3 words that you can send in for a search query. And that's going to end up making us alter our query to handle 1, 2, or 3 words. Right now we handle 3 by default. Actually, this could handle all of them, thinking about it, because these would just be blank. We just need to specify these as with default values that don't exist. Pretty cool. There's not much work involved in that. But that we're going to continue probably from tomorrow and Thursday. Tomorrow we'll be doing this at 10 a.m. GMT, and we're doing that with the officers at the same time. And wow. Okay. So tomorrow we're going to do the front end. Thursday we're going to do the work on the Spider service. And then we might even just need one more after that, just to tie up the loose ends, put the pieces together, so we get our basic search engine up and running with a front end, the query engine, and the Spider engine, basically the Spider service. That seems like a pretty cool bunch of work to do over the next couple of days. So feel free to join me 10 a.m. GMT tomorrow. It'll probably be a bit later than that for the Thursday one. I don't think it'll be the same time as this one. I have to come up with a specific time for that still. And then the last item will probably be on Friday if we need an extra day. And that'll be a full serverless application, probably over 3 or 4 parts. Depends on how that gets there. So thanks everybody for joining. If you do have any last questions before we go for the night, if you have any burning questions that you need answers to, anything like that, if you're not sure about something on serverless, if you've tried something else yourself and you would like to know or have an answer, feel free to ask now before I vanish. Otherwise, that is all that we're going to do for tonight. And thank you so much, folks. Bye-bye.